Dear students, welcome all for the course Computer Organization and Microprocessor. Myself, Kalai Selvi, Assistant Professor from EC Department, along with the Sathiyamurthi sir from IT Department. I am also handling this course. So, here in this lecture, we are going to learn about memory location and addressing. This is our learning outcome. And the SO is to learn how the memory is organized in a computer system. First of all, we have learned that memory is one of our functional units of computer system. So, the memory is mainly used for storing data or instructions. In order to store the data or instruction, we need locations. So, that location will consist of millions of storage elements or storage cells. I think you have studied in digital system design, that is flip-flop and latches. Both will act as a storage elements and that will store one bit of information. That may be 0 or 1. So, we are storing a binary data in our computer memory by using storage cells. So, in order to access these storage cells, we need address. So, we have millions of locations. Each will have single bit data. So, we need millions of address in order to access those cells. So, that is very tedious process. So, what we are doing is, we are grouping few bits of binary data into group. That group is called word. So, in memory, we will have 16 to 64 word length datas. Here n is a word length. This may be varies from 16 bits to 64 bits. Here this is our memory. Each will store one word. That is, it may store either 32-bit word or 64-bit word or 16-bit word. That is based on size of the locations. Here, in this case, I have taken 32-bit word length as an example. Here, I am going to store a signed integer in my memory. My memory size is 32 bits. So, each location will store 32 bit of binary data. For representing a signed integer in memory, since it is a signed integer, I must allocate a bit for representing a signed value of a integer. So that I have allocated the most significant bit, that is B31, for representing a signed value. All other remaining bits is used for representing a integer number. So from B0 to B30 represents the value of the integer and B31 bit represents the signed value. So if B31 value is 0, then the integer number is a positive number. If the value is 1, then the number is a negative number. Likewise, we have a ASCII characters. In 32-bit word length memory, I can store 4 ASCII character in a single location. Since ASCII character takes 8 bits for single character, so it is a 32-bit word. So I can store 4 ASCII characters in a single location. Next, in order to access the memory, either if we want to store the data or if we want to retrieve the data from the memory, we need the memory addresses for each locations. So we are having a address bits. That bit, based on the bit, we will see the number of locations in the memory. For example, here in this case I have taken the number of address bits value is 4. So by using 4-bit address, I can represent, that is 2 power 4, that value will give us 16. So in order to access 16 memory locations, I need only 4 address bits. These 16 location we will address from 0 to 15. That is what we have represented here. For by using k-bit address memory, we will access 2 power k memory locations, that is ranging from 0 to 2 power k minus 1. Now we will see how to find the number of locations in the memory. For example, if we have 10 address bits, then we will have 2 power 10, which is equal to 1024 locations, that is 1k. If we have 20 address bits, then we will have these many number of locations. We will represent 2 power 20 as 1 mega. Likewise, if it is 2 power 30, then we will represent that as 1G or 1 giga. For example, if I have 16-bit memory address, then 2 power 16 is equal to 65,536 locations. So this we will represent 2 power 10 into 2 power 6. 2 power 10 is 1k and 2 power 6 is 64. So 64 into 1k will give us 64k. Likewise, for 24-bit memory, if the address bit is 24 bits, then 2 power 24. So that can be splitted into 2 power 20 into 2 power 4. 2 power 20 is 1m and 2 power 4 is 16. So 2 power 20 is 1m. 1 into 16 will give us 16m. Likewise, for 2 power 32, we will have 4 giga. So likewise, we will find the number of memory locations in our memory based on the address bits. So in this lecture, we have learned about how the memory is organized and the number of locations in a memory system. Thank you.